Imagine waking up tomorrow and discovering that a machine learned in a single night what would take a human a lifetime to master. Sounds impossible, yet it's already happening. Every day, artificial intelligence absorbs millions of books, images, conversations, and scientific papers. It can master new games, diagnose diseases, write software, and even create art, often in just hours. But how is that possible when the human brain is considered the most powerful computer ever created? Is AI truly becoming smarter than us? Or is something else happening behind the scenes? In this video, we'll uncover the surprising science behind how humans learn, how AI learns, why one is accelerating at an unbelievable speed, and whether the future belongs to people, machines, or both. The answer may completely change the way you think about intelligence. Imagine two students beginning the exact same lesson. One spends years reading books, making mistakes, asking questions, and slowly mastering the subject. The other finishes the entire curriculum overnight. It sounds like science fiction, but that's surprisingly close to what's happening today with artificial intelligence. Every time you use a chatbot, ask an AI to generate an image, or receive a personalized recommendation online, you're interacting with systems that have learned from astonishing amounts of information. Some of these models have analyzed trillions of words, millions of images, and countless examples of human knowledge. But this raises an incredible question: if the human brain is the most sophisticated organ ever discovered, why does AI seem to be learning so much faster? Has technology finally surpassed biology? Or are we comparing to completely different kinds of intelligence? The answer isn't just fascinating, it could reshape how we think about education, work, creativity, and the future of humanity. In this video, we'll journey inside the human brain, explore the inner workings of artificial intelligence, uncover why machines appear to learn at incredible speed, and reveal the one advantage humans still possess that no algorithm has truly matched. Let's go beyond how AI learns and discover why it learns so differently from us. Before we can understand why AI learns so quickly, we first need to understand something even more remarkable: how you learn from the moment you're born. Your brain begins building an extraordinary network of connections. Every sight, every sound, every touch, and every conversation helps shape billions of tiny communication pathways called neurons. Think of your brain as a living city. Each neuron is like a house, and every new experience builds more roads connecting one house to another. The more often you travel a road, whether practicing a language, playing an instrument, or solving math problems, the stronger and faster that connection becomes. This process is called learning. But here's something many people don't realize: your brain doesn't simply store information like files on a computer. Instead, it constantly rewires itself. Scientists call this remarkable ability neuroplasticity, the brain's power to change, adapt, and reorganize throughout your life. Every mistake you make, every challenge you overcome, and every new skill you practice physically reshapes your brain. That's why learning takes time. When you struggle to solve a difficult puzzle or repeatedly practice riding a bicycle, your brain isn't being slow. It's strengthening neural pathways, filtering out unnecessary information, and building deep understanding that can last for years. Surprisingly, forgetting also plays an important role. Your brain continuously removes weak or unused connections, allowing important memories and skills to become stronger and more efficient. It's a carefully balanced system that has evolved over millions of years, not to learn everything, but to learn what helps us survive and thrive. Compared with artificial intelligence, this incredible biological process can seem frustratingly slow. So, what exactly is AI doing differently? The answer begins with one simple idea: AI doesn't learn like a human at all. The biggest misconception about artificial intelligence is that it learns the same way we do. It doesn't. AI has no childhood, no curiosity, no emotions, no personal experiences. It has never watched a sunset, felt pain, celebrated a birthday, or wondered what the future might hold. Instead, AI learns through one thing: patterns. Imagine showing a child 1,000 pictures of cats. Eventually, the child understands what makes a cat a cat. It recognizes fur, whiskers, ears, movement, even if the cat looks completely different. Now imagine showing an AI not 1,000 pictures, but 100 million. Instead of understanding what a cat is, the AI discovers mathematical relationships hidden inside every image. It calculates tiny differences in shapes, colors, textures, and countless other features until it becomes incredibly accurate at predicting. This is probably a cat. It isn't. Imagining a cat isn't picturing a furry animal. In its mind, it's performing billions of calculations to find the most likely answer. Modern AI systems rely on structures called artificial neural networks, inspired by the human brain, but dramatically simplified. These networks contain layers of virtual neurons that process information step by step, gradually refining their predictions with every round of training. Think of it like a massive team of detectives. Each detective notices only one tiny clue. One looks for edges, another for colors, another for movement, another for textures. Alone, none of them sees the whole picture. But together, they solve the mystery with astonishing accuracy. This process happens again and again and again during training. The AI compares every prediction against the correct answer when it's wrong. The system automatically adjusts millions or even billions of internal parameters by microscopic amounts. Each adjustment is tiny, but after billions of repetitions, the improvements become extraordinary. Unlike humans, AI never gets bored, it never loses motivation, it doesn't need sleep, it doesn't become distracted by notifications or forget yesterday's lesson. It can repeat the same task millions of times with relentless consistency. That's one reason AI appears to learn so quickly. But another factor is even more important. The amount of information it can consume is almost impossible to imagine. Here's a mind-bending comparison. A human might read a few thousand books over an entire lifetime during training. Some modern AI systems process text equivalent to millions of books, scientific papers, websites, and conversations. They don't read them the way you do, they analyze them at incredible computational speed, searching for statistical patterns across enormous datasets. It's the difference between filling a glass of water and standing beneath a waterfall. But if AI can process more information than any human ever could, why does it still make bizarre mistakes, invent facts, and struggle with tasks that even a young child finds easy? The answer reveals the biggest difference between machine intelligence and human intelligence, and it's far more surprising than most people realize. At first glance, artificial intelligence seems almost unstoppable. Can write essays in seconds, translate dozens of languages, detect diseases from medical images, compose music, generate realistic videos, and even help scientists discover entirely new medicines. So it's easy to believe that AI is becoming smarter than humans in every possible way. But here's the surprising truth: speed is not the same as understanding. Imagine asking someone to memorize an entire dictionary. They could recite every word perfectly, but would that mean they understand every story ever written? Of course not. That's surprisingly similar to how today's AI works. AI becomes incredibly good at recognizing patterns because it has seen enormous amounts of data. But it doesn't experience the world the way you do. It has never touched fire and learned that it's hot. It has never felt the excitement of solving a difficult problem. It has never laughed at a joke because it genuinely understood why it was funny. Every answer it generates is based on probabilities, predicting what sequence of words, images, or actions is most likely to come next, based on what it learned during training. That's why AI can sometimes produce astonishingly brilliant responses and seconds later make a mistake that seems unbelievably obvious to a human. Consider a simple challenge. Place a glass of water near the edge of a table. Ask a 5-year-old what might happen if someone bumps the table without calculating physics equations. The child will probably answer, the glass could fall and break. The child understands the physical world through years of lived experience. They've dropped toys, they've spilled drinks, they've watched objects fall. They don't just know the answer, they understand why. AI, on the other hand, doesn't possess this kind of lived experience. It learns from descriptions, images, videos, and data, not from existing as a physical being in the world. Researchers call this the challenge of common sense reasoning. It's one of the biggest frontiers in artificial intelligence today. Here's another fascinating difference: human memory isn't designed to store everything. In fact, forgetting is one of the brain's greatest strengths. Your brain constantly filters information, keeping what matters and discarding what doesn't. This allows you to focus, adapt, and make decisions efficiently. AI doesn't naturally forget in the same way. It stores learned patterns across billions or even trillions of parameters. That gives it extraordinary recall for many tasks, but it can also make it harder to distinguish meaningful understanding from statistical association. Humans ask, what does this mean? AI asks, what pattern is most likely? Those are fundamentally different questions. Here's a thought experiment. If you showed the same picture to a human and an AI, the human might notice the emotions on a person's face. Imagine what happened before the photo was taken, and even predict what might happen next. The AI might identify facial features, clothing, objects, lighting, and probable relationships with remarkable accuracy. Both arrive at useful conclusions, but they arrive there in completely different ways. So if AI isn't truly thinking like a human, why is it improving so incredibly fast? The answer lies in one powerful force that has transformed technology over the last few decades: exponential growth. And once you see it, you'll understand why the future of AI is advancing faster than almost anyone predicted. This is where Part 1 comes to an end, but don't worry, the story isn't over. In Part 2, we'll continue the journey and reveal even more surprising facts you won't want to miss. Subscribe to Beyond How and turn on notifications so you're ready when Part 2 is released. We'll see you in the next chapter.